Hello, everyone. Welcome back. So, we want to continue analyzing our SOC analysis for the ransomware attack at MediCore. So, in our previous video, we stopped at looking at the event logs. So, currently, we'll be looking at the system logs. We want to analyze the system logs. Then, first, before we start analyzing, we need to check what are we looking for in the system log. So in the system log, we need to identify the parents and child processes. Then we also want to look at file creations and outbound network connection. Then we want to also look at what command lines look suspicious. But then I need to explain this concept we want to look at because it is a bit technical. So when we talk about parent and child processes, what comes to mind? What are we talking about? In this case, parent and child processes. Okay, you can see here I said, for example, WinWord to PowerShell. That's a parent and child process. So the WinWord is the parent, then the PowerShell is the child. I will explain that connection. So, in computing, we run programs, right? We run programs whenever in computing. So when that program runs, when we successfully run a particular program, that program is called a process. So sometimes a process can start another process. Like when you're supposed to open a particular process, it can start another process. So the first process, which is the original process you wanted to run, is called the parent process. Then the other process that was automatically initiated is known as the child process. So that's called the parent and child process. So it's just like when a parent is having a child and the original one is called the parent process and the new one is the child process. So it's just the same methodology of when a mother gives birth to a child or when both parents gives birth to a child. So the parents had to meet first because it was through the connection of the parents that the child was birthed. So the parents and the child. So that's just the same process. So I'll give another example. Let's say you want to open Microsoft Word on your computer. So Microsoft Word is regarded as the WinWord file. So what you want to initiate, the process you want to initiate is Microsoft Word. So that is one process. But in this case, instead of, sorry, let me scroll down. So somehow, instead of Microsoft Word to open, another file or something else entirely is opening, that is PowerShell. So this can be due to a lot of reasons. So there can be that, there's misconfiguration, then there is an attack going on. So that's why if one process is opening another process, it happens mostly because of an attack. So the first process, which is the Microsoft Word you wanted to open, when you click on Microsoft Word, instead of Microsoft Word to open, it will open, like Microsoft Word will open, but it will open another process. That means it will start another process, which is PowerShell. So the Microsoft Word is the parent process, while the PowerShell is the child process. So that is what parent and child process mean. So this behavior is not normal. It's an unusual behavior. It's an unusual behavior. So normally, Word should not be opening PowerShell because that is not the way it works. When you click on Word, Word should open itself. It should complete that process, not trying to start another process. And in cybersecurity, this might mean a sign of malicious activity going on behind the scene on your system. Like it's usually known as a macro in Word, trying to run a script. So there's a macro attack going on, which is trying to run a script through the PowerShell. So this chain, what this is suggesting, like this chain of Microsoft opening PowerShell is a chain. What this chain is suggesting is that there is a macro-enabled document with malware on your system. So this is often known as ransomware attack. So that is how this ransomware attack was carried out. It was through parent and child processing. So there was a process that was open. You can see from our previous video where we tried, when we tried to analyze how the logs of how the attacker moved in the system. And we saw that, the attacker came in first as a user, they tried to elevate privileges, then was able to sustain their movement through the HRO server. And it was a file it used a file to activate the PowerShell process. So that is how the ransomware attack took place. So that's just a parent, and that's what parent and child process mean. So in this video, we want to analyze the system log, and we want to identify the parent and child process. We want to also check for file creation. Was there a way that the attacker created new file, or did he make use of the file that was already available in the system? Then was there an outbound network connection, which means network coming in from outside the server? Then we also want to look at what command line looks suspicious. In the command line that was used for the attack, which of them was suspicious? So we'll just go to the file. This is our system log here. So we have the event ID. Looking at our system, we have the event ID 1. UTC time. This was the time the event took place, 2025. That's the first event, which was on the 1st of April, 2025, around 10:31 p.m. So the image, there was an image uploaded. So this was the image that was uploaded. So that means there was a file that was uploaded. A file was available. Then the command line, this was the command line that was used. cmd.exe/c PowerShell, which encoded command Java. So this was the command line that was used. I'll quickly explain what this command means. So here, the cmd.exe/c is used to execute the command and then terminate. So this is what was used to execute the command and also used to terminate the command. Then this PowerShell, here is to invoke PowerShell. So in the command line, the PowerShell in the command line is to invoke PowerShell. And this command, sorry, I want to highlight that. Okay, yeah. This command is used to specify a base 64 encoded command. So this was used to specify the base 64 encoded command. So this command together is trying to send a malicious attack that will automatically start PowerShell. So it contains a malicious code. This particular command contains a malicious code. Then it was used to execute the malware. That was used to execute the malware. Then it also contains, it gives the malware ability to bypass any security measures put in place. So this command, okay, let me break it down again. The command has this command, the first part of the command executes the command and also terminates the command. Then the PowerShell in the command is trying to invoke PowerShell. Then the last part of the command is used to specify a base 64 encoded command. It's just giving the command a specification, giving it a specific order. So that's what the last part of the command is. Then the purpose of this command in this case is to carry out the malware execution, which is the ransomware attack. Then it also helps to bypass security measures put in place. So if there was any security measures put in place, this command was able to bypass that security measure. You can use this command to bypass any security measures put in place. So that was why the ransomware attack was successful. This was how they encrypted the file. Then you can see the event ID. This was the first event. The event ID 3, we have the time again, the same day. Then you can see updated execute checking. So it's now checking here. The command line, this command line was executed first on the same day. After executing this, the second time, you can see it's checking for security. So they've already successfully executed the first command line. So let's see the third attempt that was successful. So the command line for the third attempt was encryptor exe start. So here, what happened here is that they were able to start this command line here is to start the encryptor, like the encryption code. This was the command they used to start the encryption code. So by the time they were able to run this new command, then the attack has been set in motion. So I can see the target file name was user John Doe documents, HRO policy document. So you know they are working from the HRO server, right? So it was using the HRO server, and this is the target file name, which is John Doe now has taken over the HRO server using the document. So he has been able to save the malicious the attachment that was sent with the mail was able to upload it here. Image, then it was an image, Microsoft Windows current version. So this was how the attack took place. So let's go back to our guide on what we want to look at for. So what to look at for parent and child process that was in that that just happened in that log analysis. So let's go back and check for, is there any parent and child processes that happened? Yes. Okay, yes. So here you can see that they were able to upload this document, they were able to, this was where the PowerShell was initiated, this first place. So PowerShell was already initiated here. So which means they've successfully, the attacker has successfully load the PowerShell into Power. So there is a malicious software already that is starting PowerShell. So look at this place, Microsoft Windows software. So whenever, okay, the document here. So whenever this Microsoft Word is being clicked on, it will automatically start PowerShell, which is a parent and child process. Then let's go back and see what next are we looking at for. Then file creation and outbound network connection. Was there a file creation? Let's see. Oh yes, a file was created here. So this was when the user created a new file. As you can see, a document file. So there was a file creation here. There was a file creation here. So a new file was created. So first, there's the attacker made use of parent and child process, then created a new file. Created a new file. So from this log, we just read that, okay, there was a parent and child processes and a new file was created. Then now we want to investigate the network pickup file. So for the pickup file, we are just going to look at, we are going to simulate the traffic. We won't be able to simulate this traffic in Wireshark because the reason why I created it is to make you understand that whenever you are doing a real time, whenever you are doing your analysis in real time, you are going to simulate the pickup file in Wireshark. But in this case, since we are not working in real time, we are not going to use Wireshark, but rather we're just going to manually go through the pickup file and see what we can find there. So we're going to open our pickup file. So these are our pickup files. So if we were recording in real time, if we're doing our analysis in real time, you just have to upload your pickup file to Wireshark capture network. So from the pickup file, you can see we're able to import IP, TCP, UDP, DNS. We are going to create a simulated network traffic packet. So which we are supposed to do in Wireshark. Then DNS query to a malicious domain. Packet append. So this is what we're supposed to look for in the Wireshark. So we also have the TCP server here. So then we have the IP address from the TCP. So you can see we have the IP address here. So our attacker IP address, we're able to get an IP address. Then spot on. The flags, we have S here. The simulated C2 payload data infiltration. So we are going to make use of the packet appended. This was the packet that was gotten. We have the IP address here. Then the TCP spot was also gotten from the simulated payload from the C2. Then we have the encrypted payload sample too was gotten. So the file was saved to recap ransomware traffic realistic recap packet. So this is just what is in the pickup file, but we won't be able to do the analysis because we are not working in real time. That's why we won't be able to do the analysis. So next we want to show let's look at the IOC list. So for the IOC list, we want to look at the hashes, the IP address, then the file name and the domain name. Then we also want to cross-check with VirusTotal and ThreatForce to confirm, or ThreatForce. So we are either using VirusTotal or ThreatForce to confirm if they are malicious. Then we are going to add notes and severity level. So if they are malicious and we are able to find the severity level, we'll add that note to it. So let's go to VirusTotal. Let's first of all check the list. House list. Here's your house list. Okay, just going to see. Okay, so I want to say that so I will be able to pick it, upload it to VirusTotal. So we'll be able to upload it to VirusTotal. Let's just give it IOC. So we're just going to save it with IOC. So let's see, before we upload to VirusTotal, let's see. So let's see, IOC type, we have the IOC value here. So we have our IP address here. Then encryptor, so we have the encryptor here, which is ransom. May not give me a lot of information. So we can see there was an outbound connection here. Then there was a suspicious file. A suspicious file was created too, which means that just like from our previous analysis, when we analyzed the pickup file, so we're able to get that, oh, there was a malicious file that was created. So here you can see that a suspicious file was created. Then there's a validation, zero validation, then auto start key. In the command, remember in the command, there was an auto start key. Then when we, in our previous video too, we were able to establish the fact that after the attacker gained initial access and was able to elevate the privilege from a user to an admin, they were able to start, they initiated an automatic start key, so which is what is recorded here. Then the registration, they use initial access. So let's go to VirusTotal to check. just going to go to virus total. To access virus total, what you need to do is just to go to your web browser, type virus total, just click on enter. So we know how to use a virus total. So for you to use virus total, you have two methods. So say that you upload, okay, you have three methods. You upload the file. So if you are uploading a file, you are going to choose the file. But if you want to make use of a URL, just click on URL here. So you'll be able to enter URL there. If you want to search, you come here, you search for whatever you want to search for. But here you have the privilege to enter a URL. Then you can come here to upload your file too. So just click on choose file. Then how the I will see. Did I just search for the name? Okay, yeah, this is it. Okay, so yeah. Okay. Maybe because the file is malicious. Let's try again. Okay, file is not readable. Versata is not able to read the file. Versata is currently not able to read the file. So currently we can't analyze the file with virus total because it's not able to read the file. So the virus total is not able to read the file. So we'll just go back to our manual analysis. Just analyze it. Okay. So as you can see, just we've already analyzed uh, it. Then you can see there was an added email to the attack that happened. So there was an added email from here. So let's go back to our guide. So now we want to use MediCore attack navigator. This is an interesting aspect of it. So what we want to do here is just to use MediCore attack navigator, we will go back to our browser. So I'll just explain what MediCore attack navigator is. So type MediCore, just type MediCore attack navigator, then search. So what you use MediCore attack navigator for is for you to be able to map out what happens. So we're just going to click on this. So there are two ways, there are several ways to use MediCore attack navigator. So if you want to create a new file, you can just click on create a new file, then you enter, then you pick the kind of file you want to analyze. Is it an enterprise attack? Is it a mobile attack, or is it an ICS attack? So in our case, we are using enterprise attack, but we are not creating a new file because we already have the payload given to us. We just want to upload. So what we are going to do is open So we have the select layers. Okay, let me show you the options that we have. So we have the select layers here. Then you can choose to, if you want to use the select layers, then create customized navigator. So there's also an opportunity for you to create a customized navigator. But for us, we are using open existing layer. We upload. So for existing layer, let me show you this. For an existing layer, you can either upload from local file or use URL. So just like the way virus can works, can upload, then you use URL. But for let's first of all open our zip file so I can show you the file we want to upload. So in our zip file, you can see this mutual mapping. Let me open the file. Yeah. So you can see this is version 4.3. The military attack mapping is version 4.3. That was given from version 4.3. So this is what we want to map out. So you can see here the name is a ransomware case study mapping. Then the domain is enterprise attack. It's an enterprise attack. Then you can also see that the description, map techniques observed during the ransomware attack simulation. So this technique that was mapped out here, or that's mapped out here, was observed during the simulation, the attack simulation. So the techniques include the technique ID. We have our technique ID. The tactics that was mapped out is a phishing attack tactics. Then we have the comment is phishing with malicious attachment. So the comments that was given was the fact that it's a phishing with malicious attachment. That means the attacker was able to carry out this ransomware attack through a phishing attachment, like a malicious attachment. So a phishing attack was a phishing method was used through a malicious attachment. Then it enabled true. Enabled true is true. Then the color, this was the color effect. Then the technique ID, we also have the technique ID here. Then the tactics execution. So the tactics, which is execution, then the comment is PowerShell execution. So this just is map out what we've analyzed from our previous payload that we've gotten. So it's a PowerShell execution. This is just giving us a clearer picture of it, mapping it out for us. Then you can see that enabled is true. PowerShell execution was enabled in this case. Then we have the tactics persistency. So the comment here is saying registry run key and startup persistency. That was the persistency that was common. And was it enabled? It says yes, it's true. Then we have the technique ID here that talked about tactics that was used. So the tactics that was used for it here is a lateral movement. The lateral movement was used in this case. Then we have the comment SMB Windows admin share. So enabled true. It was enabled true. So lateral movement was enabled, which allowed an admin Windows share, which enabled an admin Windows share. Then we also have the infiltration method. So infiltration was over C2 channel, which is also true. Then we have the impact. What was the impact of this attack, which led to the impact here says data encrypted for impact. So the impact was as data was encrypted, important files was encrypted, and it said it is true. So, okay, start part of the file. Then the observable technique, more value one. The observed technique is, this is observable technique, then sorting. So this is just the mutual mapping. So we are going to upload this document to the mutual tab. We're going to upload it to mutual. So which is also okay. So let's go back to the browser. Upload from local browser. We're just going to pick our file, saved file. So this is it. So here in the material mapping, so we have the select controls. So we are going to pick layer control. So then there's also technique control. Now technique control here. So this helps you see the different kind of technique that is in place. So what we're just going to do layer control, we are just going to download by clicking on this download icon, then to take us to export. Then you can just click on, let's click on download. So it's already down. So when you click on this export download icon, click on this download icon. So it now say, do you want to export? Click on this sign that looks like greater than and lesser than sign. So we are just going to click on it to download. So let's see what we downloaded. Okay. So if you see, there's a difference between when the file was still raw. Okay, this from this file, let me open from our attack mapping here. So let me open the material. Okay, yeah. So we can see that the file is still raw from what we downloaded. So let's see. So here's the difference. So you see here, the version attack 17. So the name is still ransomware case study mapping. Navigator 5.1.0 layer 4.5 that was used to carry out the layer analysis. So the domain was still enterprise attack. Then we have the description, map techniques observed during the ransomware attack simulation. So filters, this was the filters that was carried out. Here we have platforms that was used. We have sorry, go back up. The platform that was used, we have Windows. You can see, okay, yeah. So platform we have Windows, we have Linux, we have Mac OS, then we have network devices also that were used. So these were the network devices that were used. This we have the EXXI and we have the PRE. Then the containers that was used was SACS and IaaS. So the office suite was identity provider. So you see, this gives a clearer understanding of what happened and a clearer picture of the whole attack. Then sorting the layout. So the layout function here we have average. Then shows show ID. So the aggregate layout, okay, the layout by side now. Aggregate function is average. Then show ID first. So there was no ID that was shown. Then show name. Yes, we were able to identify the name of the person, which is John Doe, was all the name the attacker was using. Then show aggregate scores 4. Counts on scored 4. Expenditure substantial none. Techniques none. So we have high disabled techniques 4. So the techniques we have here, we have let's see the techniques. Okay, the technique ID. Okay, tactics was phishing. Comment said phishing with malicious attachments, enable true links, then show sub techniques first. We didn't have any sub techniques available after the mapping. Then we can see that the technique ID here, execution, they said comment PowerShell execution. So the attack allowed from the command, there was a PowerShell execution, which is saying agreeing that it is true. We have the technique ID, and yes. So just similar to what we established before, that then the data was encrypted. So the impact of this command that was used and the attack is the fact that the data of the organization was encrypted. Then the sub techniques is false. So this is basically how the information we've gotten from the mapping that took place. So this is what we've gotten from the technique. So we are just going to observe the last phase. Yeah, so we are going to review the payload script. This is optional. You can try to review the payload script or just go on without reading the payload script. So for the payload script, it says, we're just going to look at it. They understand what the attacker simulated by creating ransom nodes, renaming file, and network trafficking. So we're just going to look at the payload. So open the payload. I'm not able to set the payload. Let me see. So I'm not able to open the payload. So I am not able to open the payload currently. So, but this is optional. This is just going to show you the back end of how the script was written, just the back end part of the attack. So this is all about the analysis of the MediCore's ransomware attack. So in my next video, I'll be showing you how to write your report, the important details that should be in your report, the format and technique which your reports will take, the form which your reports will take, and the important things that should be in your report. Thank you for staying with me this far. See you in my next video where we'll be looking at report writing. Thank you so much.